All right, margin of error. We already just went over. That is plus or minus 2 times my standard deviation. Confidence interval. How do I find it? That 95% confidence interval. I do what? I take whatever the mean is, add and subtract my margin of error. Okay? Add and subtract my margin of error. This next one we totally forgot about on the quiz, some of us. Interquartile range. Yeah, you just don't find Q3 and Q1. Some of you did that. You got to actually subtract the two bad boys, all right? Q3 minus Q1. Where can those values be found? One var stats. One var stats. All right, I put normal distribution on there. That's not a formula. I just want you to know if we're going to see that a ton tomorrow on the test, what should go through my mind when I see in a problem that scores are normally distributed. All right. First thing that should go through my mind is the curve. It fits the curve. Okay, fits the curve. And I'll show you there's a ton of examples we're going to go over today. The other thing I should start thinking about is what on the calculator might I have to use? Not every time, might I have to use? Normal CDF, yes. Not every time. Only certain times I'll go to the calculator, and I'll show you when we do the examples. And the other thing I would definitely remember going into tomorrow is what's that represent? 95 and 68. 95 is within 2. Hey, do you see the relationship? 95% confidence interval? That's within 2 standard deviations. Never mind. All right. And then 68 is within 1 standard deviation. And make sure we'll go over it, but make sure you can find from -1. Do you know how to find the score at -1 and 1? Do you know how to find the score at -2 and 2? Okay. You ready to get it going here? Ready to get it going? All right, I'll save all the jokes to the end. We're just grinding through these right now. Not every single one, but ones that are important for tomorrow. Back of your packet. Oh, sorry, my fault. I got one more thing to review. Putting numbers into a list. Okay, we all know how to get to this screen. Stat edit. Okay, after I go to stat edit, I usually go to one var stats. That's the only place we've been. All right, the one thing I want you to be aware of, how many lists did you put it in? Be aware of that. If you just put it in one list, just L1, nothing else. If you put something in L2, the L2 is where it's list. Okay, we all good so far? So this right now, here you go. We're at one var stats. What's the X bar? Mean. These two right here, SX and OX, are the what? Okay, standard deviations. SX is called the sample and OX, population. If nothing's stated, we use the population. And then down here is where you get Q1 and Q3 to subtract to find your interquartile range. Everything else you don't need to worry about. All good. Ready to roll? Let's do it. Number 1 in the review section. Number 1. Yep, we're ready. Hello, Gabe. How are you today? I'm doing all right. Thanks for asking. All right, here we go, everybody. Elizabeth waited 6 minutes at the drive-thru for her fast food order. Again, I'll do all the jokes at the end. There's so many here today. The manager said, you know what, that's a little unusual. It won't happen again. So there was a study done, and the average time was 226 seconds. Deviation was 38. Is her wait time unusual? Using a 95% confidence interval, was her wait time unusual? Well, let's find the interval. Let's find that 95% interval for me. How do I find the interval again? I take the mean, add, and subtract the what? Oh, for the confidence interval. Add and subtract, not the standard deviation, my margin of error. So it looks like I'm going to have to go off to the side and calculate that. My margin of error, plus or minus 2 times what number up here? 38 seconds. Plus or minus 76 seconds. So that tells me, okay, that mean that they gave me of 226 could be off by 76 seconds in either direction. All right, now let's find the confidence interval now. Mean was 226. Go ahead and add and subtract that margin of error of 76. And let's see the interval, that 95% interval. So we got what, 150 to 302. Okay, is her wait time unusual? Don't do this. Oh, 6 minutes. 6 falls way outside, so it's unusual. This is in what? Yeah, okay, let's talk about that. So 6 minutes, I can't just use here. 6 minutes, 360. All right, now take a look at 360. Where does it fall? Outside. So was her wait time unusual? Yes, it was, because it falls outside my 95%. Yes. All right, so Elizabeth's wait time, 6 minutes. That's not fast food. So yes, because it falls outside the 95% confidence interval. How was that one? Not bad? Anything else? Next one. There it is. They're approximately normally distributed. All right, we got a lot of options now. Within this curve, 95% of the heights are between 62 and 78. Ready? Right, here you go. Normally distributed. You tell me, where can I put 62 and 78 on this curve? Well, I'm not ready to go to the calculator yet. Where can I put 68 and 62 and 78? 95%. Where do I put it? Negative 2 is going to be what? 62. And what's positive 2? 78. Yep. I don't need the percents. The calculator will give me the percents later. I don't need that. What I need to know is use this information to estimate the mean. Where's the mean on the curve? All right, help me. Help. How do I get to the mean? Okay, well, now where do you want to? We can start on either side. Do you want to start at 62 or 78? 62? Okay, so how do I go from 62 to the mean then? Why 4? What's 4? Add the standard deviation. So go ahead, add 4. You get what? 66, but that's not at 0 yet. Where's that bring us to? That's at negative 1, 66, and then do what again? Add 4 again. What's my mean? Mean is 70. It's a 2-part problem, though. Ian, you all right? Ask away how we got to that center point. Okay. Find the, I know we don't like that word, probability that a male student is taller than 74. Probability, find the percent. Either one's fine, probability or percent. Where can I get that number from? Taller than 74. Because, hey, I have no idea. I didn't memorize the percents under here. But what has the percents there, Langston? Your calculator has the percents if I go where? Yep. Normal CDF. All right, I'm still nervous about this. Even though you know where to go, I'm still nervous. Taller than 74. What is the lower bound? Nice, 74. Upper. 1E. Yeah, go. It's your job. 1E99. Mean, good thing they asked us to find it, right? Because we would have been lost there. 70 with a standard deviation of 4. We've been working with percent, so let's keep it that way. Round to the nearest tenth of a percent for me. Round to the nearest tenth of a percent. So what's the chances a student is 74 inches or taller? About 15.9%. Yep. Anything? JT, you all right? Anybody else? Seven. Okay, quick, because I can't keep doing this math over and over. We're doing weight of a box of cereal. Cereal preferences in here. Quick discussion. Hurry up. Ooh, are you just the marshmallow person, or do you eat everything? Okay. Cinnamon Toast Crunch. All right, I got you there. Yep. What? Life. Okay. I'm all right with that. Oh yeah, you go, Dom. Honey Nuts. Yep. Ugh. Either go regular Cheerios or Honey Nut. That's it. Or I do a little multi-grain. No. Anybody else? Fruit Loops, Tricks? Anybody else? Cereals? Anybody throw bananas or strawberries in there? I throw bananas in it.
I feel like that's such like a dad thing. Because my dad does it.
Well, also, and probably you're not going to understand why, but I also throw some animal crackers on top too. You can put milk in there, right? Animal crackers and milk go together, so I throw some animal crackers on top. No. I don't wait an hour until I eat them.
Yeah, you can't put too much milk in it.
True. I agree with that. Oh, cereal first. No. Nope.
Yeah, but if I have extra milk in like the bowl after, I'll put more cereal.
My mom puts ice in her cereal because she ice cold.
Yes, my dad does that too.
Okay. I've never heard of that one. Anybody just, if there is milk left, you're doing the whole right in there? No? What? Yeah, I would. Yeah, I'm not drinking the rest of that. What's that? Yeah. It's fine. I don't care. Unedited. All right, good discussion on the cereal. So let's get to this one here. The weights The weights of all the boxes, hey, take a look. They're approximately normal. Perfect. So I know this resembles the curve with a mean of 20 and a standard deviation of 2. All right, first question, part A. Give me the range of weights that are, within 1.5. We've talked about 1 and 2, but we've never talked about 1.5. So could you find me on this graph which number represents negative 1.5 and which represents 1.5? You can do that. You have the ability to. All right, don't get all nervous because it says 1.5. First of all, what's the mean? What's the mean weight? 20, and you know on the curve that's at what number? 0. So ready? Hey guys, at 20 it's 0. What's the standard deviation? 2. So tell me what weight should be at 1. 22 should be at 1. What weight should be at 2? 24. So hey, wild guess. Which weight's at 1.5? 23. Can you go backwards now and find out which weight should be at negative 1.5? So it should be from what to what? From negative 1.5 to 1.5, which are what weights? 17 to? You guys can do this. Come on. Confidence. And I'm going to let you do part B. Read it on your own. How many boxes of cereal are more than 1.5 above the mean? How many boxes of cereal are more than 1.5 above the mean? We know where 1.5 is. I'm just nervous you're going to pick one that sucks you right in. Okay, so let me ask you this first. What numbers up here are more than 1.5 above? 24 and 25, right? Those are the only two that are above. So I'm hoping you just didn't circle 2 right here. This 2 here. Hopefully you did it because there's just 2 values. No, you got to look over. Ready? 24, how many boxes? Plus 25, how many boxes? So total, how many? About 6 boxes. Yep, about 6. Do we see how we got the 6? Good there. Questions? Wait till this next one. Is this the one I'm thinking about? Nope, not yet. 11. And there is a typo here. Sorry. It goes from this guy to Eli. All right, it goes from those 2 there. So I think that's how you pronounce it. I don't know. It's just like a farm animal sound. No, I'm not going to again. No, I couldn't even do that if I tried again. All right. All right, ready? Normally distributed, the test. Hers, I don't know, scored a 246. The mean was at 182. You got the standard deviation of 36. This term is new to us, so let me explain it to you. I'm not going to put it on this term on the test tomorrow, but I could reword it. All right, so you could have to find it. Percentile rank. Ready? Here's your percentile rank. That's the percent that scored at or above. The percent that scored at or above. Or below, sorry. God darn it. I started thinking about something. Yeah, exactly. One job. See, this stuff comes back to bite me. Or below. Okay. Can you help me find the percent of people that scored at or below Eli's score? What do you know about these scores? Distributed normally. And I'm trying to find a percent here. Where should I be going? If normally distributed, trying to find a percent that scored at or below his. Normal CDF. Yep, let's roll. at or below. So what was his score? 246. So ready? At or below 246. So what should be my lower bound? Yep, negative 1E, 99. How about your upper bound? 246. What was the mean? 182. Ooh, he did well, huh? He did pretty well. Standard deviation, 36. Let's go nearest percent on this one. Nearest percent. He did pretty well, huh? What's his percentile rank? Yeah, 96 percentile. It's pretty good. 96% scored at or below his. Only 4% better. We'll take it. We should do this for a test or something, huh? I'll give out the mean and the standard deviation. You can see where you rank in the class. Huh? Be a killer? No. No? And you calculate your own percent, and then anxiety and depression sets in. Yep. Yeah, why don't we keep it that way? How'd fifth period do? All right, everyone all right on that one? Using your normal CDF? I got 2 more here. Just stay with me. Oh, 3 more, excuse me. Stay with me for 3 more. 12. This is a good one, huh?
If you could be any animal, what would you be? A giraffe?
That would be a cheetah.
Yeah, I was just about to say that. Or leopard. Okay, here we go. We could read, okay, the gestation time, number of days before birth for the cows, normally distributed, mean of 284 and a standard deviation of 12. So at one of the ranches, they had 820, births. Of these, how many would it be expected to be between 270 and 290 days, the gestation time? So out of those 820, how many of them would be between 270 and 290? Well, I can't figure that out right now. I would need to know the percent that are between there, right? So I need to find the percent that are between 270 and 290 so I can multiply it by the 820. How do I find the percent that were between 270 and 290? Go to the calculator because it's normally distributed and I'm looking for a percent. But there should be no E99 on this problem. That's why I picked it. Because what is your lower and upper that they give you? 270 for your lower, 290 for the upper. Mean of 284 and a standard deviation of 12. Now, if you know you're going to have to multiply this number by something, keep that whole decimal in your calculator right now. Okay, keep that whole decimal. Don't round anything. Okay, just keep it all because you know that's not going to be your final answer. So keep that whole thing in your calculator right now, which I did as well. Point. So about 50, what are we saying, about 57% of them? Okay, so how can I use that 57% and there's 820 total? Multiply, yep. So how many were between 270 and 290? About, make sure we get whole births, please. Not a leg or two. 400, about 467 births. Yep. And then we couldn't do a review without doing a significant or not as significant, right? Last one, 19. I think it's the last one. 18, yep. Yeah, I know. It goes 19, 18. I get it. All right. Yeah, I get it. One job. Yeah, I get it. Yeah, I get it. These stories are great. It is. That's the problem. Close. New variation of the monarch butterfly. Without doing any simulations, I think we can all agree he's got a lot of time on his hands. Yep. New pattern for the new butterfly. Yep. All right. So bottom line, he did the butterflies, traditional butterflies, measured their wingspan. You guys might have to do that tomorrow, but I did it for you already. The difference in the two groups is 0.5 centimeters. Okay, the difference in the wingspans. All right, quick question. Tomorrow, if I say, what's that 0.5 mean in context to the problem? On average, which new butterflies had a wingspan of 0.5 centimeters greater than traditional butterflies? Okay, on average, that's what that means. Okay, we do the simulation. Everyone see where 0.5 is? There it is. And we count how many are at or above, in this case, 0.5. There's 7 of them. And go back, quickly reread how many different simulations did I do? 70 resamples, so 7 out of 70. This will tell us if that is significant or not. %, or at or above. Is that a significant discovery? Significant discovery or no? 10%. No, it's got to be 2.5 or below to be significant or unusual. So, all right, not significant. Because it falls where? With not outside, falls within the 95% confidence interval. The other way you could do this, and I'm not saying you have to, but if you're really confused about this, the other way is actually find the 95% confidence interval. How do I do that again? Quick review. How do I find the 95% confidence interval? I take the mean and plus or minus my. Okay, so what you could do is you could go into your list, do -0.8, -0.7, all the way to 0.8, and then do the frequency right next to it and write in how many there are. 1var stats, get the mean and standard deviation, and actually find the interval, and you'll find that 0.5's on the inside of it. That's the other way to do it. Just put it all in your calculator and find your own 95% interval. Okay? Questions? Got one more for you. It's the previous one. It's called 19, even though this was just 18, I know. And that is population versus sample. Because I do ask one of those questions tomorrow. I'll give you a scenario. Yeah, there he is. Population. And what's the sample? Remember, this is who we're testing, not what we're testing. All right? This is who we're testing, not what we're testing. So read through it. What is the entire population we are testing here? How can you describe that? The entire population. I don't want to know what we're testing, just or what we're testing, who we're testing. So what is the entire population being tested here? All. What are we testing here? Who are we testing? all 2018 Edge SUVs, right? All of them. That's our population, but that's impossible to do. That's impossible to do, so we break it down even smaller. So what's our sample? 100, yes, of those Edge SUVs. What's a controlled experiment? That's the big thing. 2 groups. One gets the treatment, the other gets placebo, some type of fake treatment. All right? Anything else? Comments, concerns? All the rest of the answers are up on Aspen if you want to try them out later on tonight. We ready to go for this? Only 31 points. There's not much to get here. You ready to grind away on Thursday and Friday? Hey, anybody want to give me your prediction, region score? Yep.